Hello, we here discuss remaining part of electrochemistry, uh, that is applied electrochemistry. This part include in a same topic, same unit of elect- electrochemistry, paper 1 for semester 6. We discuss here first point from applied electrochemistry, that is polarization. If we consider any cell which consists of two electrodes, anode and cathode, connected to source, positive and negative terminals of the source, and electrolyte solution, that is solution which contain cation and anions, and that electrodes are dipped in that solution. That two solutions are connected by salt bridge. When that an electrode is in contact with solution containing ions, there is passage of current through the solution, and therefore that is when current start to flow, that respective reactions at anode and cathode, that is oxidation at anode and reduction at cathode, start to take place. And because of that oxidation and reduction at anode and cathode, there is change in concentration of positive and negative ions takes place, observed at the vicinity of these electrodes. That is, we know that at oxidations, because of oxidation at anode, positive ion concentration increases. During oxidation, there is generation of positive ions. Therefore, at the vicinity of anode, there is higher concentration of positive ions, and in the vicinity of reduction reduction electrode, that is cathode, that reduction results in decrease in concentration of positive ions, neutralization of positive ions. Hence, that results in increase in concentration of negative ions. If copper sulfate is there, Cu plus plus neutralizes in reduction, Cu plus 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 2 electrons, that gives Cu solid, which deposited on that electrode, and because of that SO4 minus minus ions remains at the vicinity of that cathode, and this distribution of positive and negative ions in a solution is known as polarization. Distribution of positive and negative ions in solution is known as polarization. There are different type of polarizations, and one of the polarization type is concentration polarization. This is because of this concentration difference in concentration of ions in solution. That ion concentration is different at different regions in that electrolyte solutions. That is, at vicinity of anode, positive ion concentration increases; at vicinity of cathode, negative ion concentration increases; And this increase in concentration, because of this difference in concentrations generated at the vicinity of electrodes, that becomes difficult for further reactions, so as to continuation of redox reaction, that is reduction and oxidation at respective electrodes. This concentration difference becomes that made that because of that concentration difference, that further reaction, continuation of reaction becomes difficult. That is because of increase in concentration of positive ions at the vicinity of anode, that decreases the speed of oxidation reaction, that decreases the speed of oxidation reaction. And at the vicinity of cathode, negative ion concentration increases, which also decreases the reduction reaction speed, because that negative ions which are present at the vicinity of that electrode cathode, they stop the flow of positive ions towards that electrode cathode. Because of that cage of negative ions, entry of that positive ions towards that electrode becomes difficult, and that decreases the reduction reaction. Similarly here, in case of oxidation at anode, that because of increase in positive ions at the vicinity of that electrode anode, that further entry of positive ions becomes difficult, which minimizes the speed of that oxidation reaction. And therefore, so as to this difference in concentration or polarization takes place because of this concentration difference at anode and cathode is known as concentration polarization. So as to minimize this concentration polarization, that electrolyte solution is continuously stir continuously. Because of stirring that positive and negative ions from that electrodes, respective electrodes, they migrated throughout, they spread throughout the electrolyte solutions, and that will become uh, that will become easy continuation of that electrode processes, reduction and oxidation at respective electrodes. Therefore, this concentration polarization can be minimized, not made to zero, but can be minimized by stirring the solutions continuously. Then next point is decomposition potential. When electrolysis of solution is carried out between two electrodes, then because of polarization, the discharge of ions at respective electrodes becomes difficult. Discharge of, that is at anode oxidation and at cathode reduction processes becomes difficult, and therefore it is necessary to apply the external voltage, external EMF, so as to uh, uh, carry out this oxidation and reduction process continuously without any difficulty. This minimum voltage that must be applied across the two electrodes in electrolyte solution so that continuous discharge of ions takes place. That is known as decomposition potential. That is minimum voltage required to apply between two electrodes so that or so as to carry out redox reaction smoothly, or so as to carry out that electrode processes smoothly. That minimum voltage required to apply is known as decomposition potential. Then experimental determination of decomposition potential. The experimental determination of decomposition potential for any electrolyte solution using two electrodes. That experimental setup is shown here as in figure. That is, two electrodes are placed in electrolyte solution, and so as to that two electrodes are connected, and that are um, there is a voltmeter is connected between two electrodes so as to measure the voltage across that two electrodes, and that also um, um, connected to rheostat so as to change the resistance between that two electrodes. That also connected to ammeter. Ammeter is also connected in this circuit so as to measure the current flowing through this circuit. Then initially small voltage is applied and current is measured for each voltage. Voltage is slowly increases with the help of this rheostat, that is variable resistance, that instrument which changes the resistance, therefore that changes the voltage between these two electrodes, that is known as rheostat. And through this by using rheostat we increases slowly that voltage applied between these two electrodes, and for each voltage that current is measured with the help of ammeter, and we plot the graph of applied voltage against current. Then it is observed that up to certain voltage there is small increase in current with increase in applied voltage, but after certain voltage there is sudden increase in current with small increase in applied voltage. That AB line shows small increase in current with increase in voltage, and that PD line shows sudden increase in current because of increase in applied voltage. Then this that two lines extra plotted, and there is a point at the intercept of these two lines AB and PD. The voltage corresponds to this point C is nothing but applied voltage. Applied voltage at that point C is nothing but decomposition potential, value of decomposition potential for that electrolyte, electrolyte solution. Here, initially why there is small increase in current with increase in applied voltage? Because that electrolysis of that electrolyte solution is not not takes place, not start to takes place, that voltage up to point C is not sufficient. Initial voltage is not sufficient to carry out oxidation and reduction reactions at respective anode, at respective electrodes. Therefore, there is a small number of positive and negative ions, but that electrolyte is that very small uh, rate of oxidation and reduction is very small number of generated positive and negative ions up to point C, up to voltage C. But at point C, voltage is sufficient to carry out oxidation and reduction, which overcome that all difficulties in that solution to takes place oxidation and reduction processes smoothly. And therefore, after that voltage, that electrode processes smoothly takes place fast, takes place start to takes place fast, and that increases number of positive and negative ions at anode and cathode, and which therefore increases the current suddenly, and therefore that voltage at point C is nothing but decomposition potential. Then next, factors affecting on decomposition potential. The decomposition potential of any electrolyte solution depends on nature of electrodes which are used. Then that also depends on type of electrolyte, that is which electrolyte is used, which cation, which type of cation and which type of anion is present, and that also depends on temperature. These three factors affects on value of that C, that is decomposition potential of any electrolyte. Then afterward we discuss next point during next lecture, that is concept of over voltage. Concept of over voltage. Thank you very much.